Hello, everyone. I'm Mike Richter, president of Brightcore Energy. Welcome to the first video in our geothermal series. We're going to be discussing the fundamentals of geothermal. Today, cities everywhere are facing challenges of reducing their greenhouse gas emissions. In New York City, for example, buildings emit approximately 70% of the city's greenhouse gas. For 55% of those emissions, HVAC is the culprit. In order to reduce greenhouse gases in cities, we must address the impact of heating with fossil fuels and adapt to a cleaner method of heating and cooling our buildings. Back in 2019, New York City introduced Local Law 97, which sets carbon limits on large buildings. These carbon emission reductions are primarily driven through electrification of heating via heat pumps. One type of heat pump technology which is underutilized in New York City is geothermal energy. This sounds odd given the density of the buildings, but the heating and cooling for geothermal energy is not a novel technology. It's been used in the US and Western Europe for quite a bit of time. I'm here with our VP of Renewable Heating and Cooling and resident geothermal expert, Dave Hermantin, to talk more about how geothermal works and how it plays into the advancement of clean energy and electrification of heating and cooling. Dave.
Thanks, Mike. I'm really happy to be here today. First, to be clear, we're not talking about the type of hot rock geothermal that runs steam turbine power plants, but we're talking about ground source heat pump geothermal. Here in New York and most of New England, starting at about 20 feet down to about 1,000 feet deep, the Earth's ground temperature is between 50 and 60 degrees all year round. The reason for this is mainly solar radiation that doesn't reflect back to the atmosphere and heats the ground. Geothermal systems leverage this temperature by extracting heat from the ground in the winter to heat buildings and reject heat to the ground in the summertime to cool buildings. And while 50 degrees doesn't seem cold, it seems a bit cold to heat your building. 50 degrees is much warmer than the 20 to 30 degree temperatures of a northeastern winter. Geothermal heat pumps boost this 50 degrees from the ground to a normal indoor temperature of about 70 degrees. In the summertime, indoor heat's removed from the building where it's rejected to the ground, keeping the indoor temperatures cool.
That's interesting. So, Dave, it's clear that using the ground temperature as a starting point instead of the outside air temperature, whether cooler or heating, makes the system very efficient. As many of you have experienced, for example, it's much easier to heat up a car in the garage instead of outside in a parking lot in the dead of winter. Maybe just give us a little bit more insight into that, Dave.
Yeah, that's right, Mike. The ground source heat pumps are extremely efficient because of this ability to leverage ground energy. It's well documented that ground source heat pumps are the most efficient type of heating and cooling equipment. And in fact, ASHRAE has installed and tested ground source heat pumps and VRF systems at their headquarters in Atlanta, Georgia, and the geothermal systems perform significantly better than air source heat pumps. And again, energy efficiency is so important, especially as we transition from gas to electric for heating. We're hearing more and more concerns from grid operators that winter electric peaks could cause problems for them. And the advantage of geothermal is that their COPs are very high, and even the coldest times of year, they really perform well. As you see in the graphic here, efficiencies from these systems can reach more than 400%, resulting in less electricity used, and that's critical during high demand periods.
So what is a COP?
Oh yeah, COP is it's an acronym. It stands for coefficient of performance, and a way to picture like a 400% efficient or a COP of 4 system that has a COP of 4 is to picture an electric resistance heater, the type that you plug into the wall and it glows. It's turning the electricity directly into heat. Those types of heaters, they are 100% efficient, and they have a COP of 1. It's taking 1 unit of electricity and turning it to 1 unit of heat. Heat pumps, they leverage thermodynamics to boost energy. So when you plug in or connect your electricity to a ground source heat pump, it takes that 1 unit of electricity, but it also leverages that ground temperature to give you a COP, or a coefficient of performance, of 4 or even higher.
All right, that's very interesting and it makes total sense. We certainly don't want to create a new problem by solving an old one. And I guess the key here is when we go to building electrification, we're ensuring that we're using the most efficient technology available.
Yeah, we need to be very efficient, but equipment needs to be reliable. And renewable technologies for heating and cooling are necessary, especially in New York City, where we're trying to achieve these greenhouse gas emission reductions and the goals set for 2550 and 2550. And geothermal can do this.
So you mentioned that these are incredibly reliable systems that do not require much maintenance, and that's fantastic. But then you have to ask, what are the market forces that are helping drive this adoption? The technology looks viable. How can we get it out there?
Well, yeah, like we mentioned before, New York City and New York State are strongly committed to climate goals, and that's specifically reducing greenhouse gas emissions. So regulations like New York City's Local Law 97 and New York State's CLCPA, as well as natural gas moratoriums in Westchester County, are the stick. The utilities are providing the carrot by way of real generous incentives for heat pumps. That's really driving the market to install more heat pumps.
All right, so that's fantastic. I really appreciate you joining us, Dave, for this first installation. So just a synopsis: we're moving buildings off of fossil fuel because it's just critical we do it, understood. You have to move to the most efficient technology, and geothermal heat pumps are exactly that. They're robust in terms of their maintenance and their ability to be reliable. And there's enormous market incentives, both carrot and stick, to make this happen.
That's true, Mike, and I'm glad to have the opportunity today to talk about this with you and everybody watching.
Thanks, Dave.